Hey, I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
The podcast that helps you understand the chemistry of your everyday life.
Jam, what's up, what's up, what's up?
Dude, not a lot. What's up with you?
You know what I was just thinking about and that I'm really excited about?
What's that?
Okay, well, I'm a scientist. That's the whole...
Hey, okay, so why are you just not telling me this?
That's the whole basis of our podcast, but I felt like I needed to preface what I was about to say with that.
Uh-huh.
So I really like certain types of data, especially if it's already available to me and I don't have to analyze it.
Yes.
And on our podcast page, there is data.
Yep.
And I've been creeping on the data and checking things out, and it's been really fun. And we have listeners in like 20 countries besides the United States.
Yeah, which is pretty great. If you're one of those listeners in a different country, hit us up on social media. Let us know that you're listening.
Yeah, say hi to us. I'm so excited. There's people in Mexico, in Canada, in Sweden, which is the best because that's where my favorite hockey player is from. We have Australia and Mongolia. That is so cool. Mongolia, say hey to us. South Korea, give us a what's up. I'm so excited about this. This is so fun to me to watch it spread.
Yeah, it's pretty crazy. It's also cool because it's like 1 or 2 or 3 in its countries, and like we're like gone crazy yet. Mm-hmm. But it's kind of cool to think like, man, there's one person there, so it'd be cool to hear who you are. Like there's one person, 1 or 2 people in these different countries. So let us know who you are.
Yeah, let us know who you are. Say hi so that we can say hi back and be so excited for new friends. Woo! Anyway, I just got really hyped about that. I've been like, oh my gosh, look at all this fun informational data. I just want to look at it and break it down and think about it.
I have a kind of funny story of something that happened this morning. We didn't know this was going to happen. I think my wife knew, but we weren't all in the know that an exterminator was going to come this morning. Mm-hmm. And so he showed up, and he doesn't need us to really do anything. He just rang the doorbell, I guess, to let us know. And so we normally would, put the dogs inside and stuff. Mm-hmm. And so he just started doing his thing, spraying, he comes every quarter. And so it's preventative, and also we have some stuff that like it's an older home, so we want to make sure there's not any termites. And so just a good idea. So he started walking around the house, doing his thing on the outside. And he went into the backyard, and both me and then one of my roommates who lives in a different part of the house were getting ready. And because we didn't know he was going to come, my roommate said that he was getting ready and was definitely naked and definitely looked out the window and definitely saw the exterminator and didn't expect that he needed to have his window closed because it's to the backyard. And so he's pretty sure that the exterminator got a little bit of a show. So it was a funny and not super usual morning event.
Is your roommate okay? I mean, is he the kind of person that's heartbroken that happened?
I don't know. I think I guess no one would pick that thing to happen, but I think he can take those kind of situations in stride and make them into pretty funny stories. So yeah.
Can you imagine just looking up? Did he make eye contact with him? Because that would be even better.
That would be, I don't know. I haven't heard the full thing. I just heard this update via text earlier. Oh, man. But anyway, so that was my morning.
That's good.
What's happening in your world other than the stats stuff?
Not a whole lot. I'm here in Denton, and I'm working in my last few days of research without classes starting yet. Uh-huh. And just trying to make the most of my time before it gets crazy again. So
awesome.
It's just been good. Even keel. Easy going.
Yeah.
Yeah.
Very cool. What is the thing that I'm supposed to learn today?
Well, and I mentioned this in our last episode.
Oh, yeah, that's right. We gave a little bit of a tease.
The idea for this came to me when I was with my sister and brother-in-law, and he was making us dinner. He makes this really good lobster pasta, and he put on some water to boil for the pasta, and he threw the lid on there, and I said, do you know why people put lids on pots while they boil? And he had an idea of what it might be, but now I'm asking you. Okay. Why do people put lids on the pots when they're boiling water?
Okay, good question. Okay, my initial thought I think is just that like your heat source when you're boiling something is on the bottom and heat rises and it feels kind of like if you just left it open the whole time, that it would take longer to boil, and it feels like maybe the heat would dissipate a little bit more because then the top is open, and it would like, obviously everywhere else is room temperature, so would it like kind of cool while one part's being heated with the other part cool. So I kind of just thought like if I put a lid on it, it prevents that.
Traps the heat, basically.
Yeah, traps it, but also like, because like if you put a lid on, then you take it off, you'll see like the steam or whatever, the condensation. So it's like, okay, definitely something is going on.
Yes.
So it's, if I can keep a lid on that something that's going on, then maybe it'll boil faster.
Okay, well, I'm not going to tell you whether or not it will boil faster or whether or not your feelings are right, but let's dive into what's going on, the something going on that you see.
Okay.
Do you know what boiling point is? What is the definition of a boiling point?
The temperature at which substance boils.
Yeah,
that it?
That's a little bit like when you say, what is resistance? And the answer is like the act of resisting.
Yeah.
That's what you just gave me.
That is kind of it. But that's all I know. I mean, that's my honest.
That's your honest answer.
Attempt,
the act of resisting. So boiling point is that boil that you see. Everybody knows what boiling is. That is what happens when the vapor pressure of the liquid substance is the same as the atmospheric pressure. So just living here on the planet, you look mind blown.
I just thought of something, but keep going.
About this?
Yes. Well, yeah, it's related.
Okay. Do you want to share it now?
Well, I just was thinking about a moment ago before we started recording, we were talking about how I have family that lives in Bolivia. They live in a super high altitude area.
Yes.
Guess what?
What?
The boiling point is a lot lower.
I was literally going to ask if you knew that.
It's freaking crazy. They have to change a lot of stuff when they cook, and there's like, it would affect everything. I've thought about like, what if I go over there in a few years and I need to make coffee? It'll adjust. I have to adjust some stuff that I do.
Yes.
It's just like, sorry. Yeah. Like I realized all of a sudden, like, whoa.
Yes.
I'm going to understand this better here in a little bit.
Well, I was going to ask you about that. I was going to say, now that you know the definition, do you think water always has the same boiling point? Because if I said, what is the boiling point of water? Everyone always says
212 Fahrenheit.
Yeah.
Or
That's
100
what
Celsius.
That's what 212 Fahrenheit is what all the non-scientists say. I don't know the boiling point of water in Fahrenheit off the top of my head ever.
Oh, really?
Yeah,
it's just 100 Celsius though, right?
Right. So
it's
we
like
live
nice and easy.
Right. We live in the world of science where, so to us, room temperature is 25, water boils at 100, water freezes at 0, and those are facts. And
Isn't that so nice? Those numbers are so convenient. Man,
they are.
I love that. I wish I knew Celsius better.
All my numbers of what things boil at and all of that is in a different category in my mind than what we're going to set the thermostat to.
Yeah.
I wish that we went by Celsius and everything, but it did come in handy when we were in Europe because I could figure out the temperature relative to that. I would do some quick conversions and say, well, it's probably this.
Yeah.
So
I've been in a lot of different countries where I've had to do that, and I like every time I have to reteach myself the quick method, the like quick in your brain method to get a rough guess of what it is. And every time I travel overseas again, it's like I have to relearn that. It just never stays. Yeah.
So everyone always says, water boils at 100 or water boils at 212. And that is right if you're at sea level. But it's not exactly right. It doesn't change by a ton. But because boiling point, the definition is when vapor pressure meets atmospheric pressure, that changes based on what atmospheric pressure is.
Yes. Okay, so at a higher altitude, is it higher atmospheric pressure or lower?
Lower. So an atmospheric pressure, you can think of it as all the pressure from the atmosphere of the earth. So whatever gases and everything are up above us pushing down on the earth.
Okay.
Or coming down on the earth. So all the pressure that's on us when we're walking and talking and all of that, if you're at sea level, that's one atmosphere of pressure.
Okay.
So that's the standardization or standard. I don't know if standardization is a word. They standardized boiling points with the one atmosphere pretty much.
Okay.
And it doesn't change just a ton, but it is enough to change the way you cook or whatever. Okay. Another way to think of it that's a little bit easier than when vapor pressure meets atmospheric pressure, this was a way that my advisor gave me to think about it, is that basically the water molecules that are turning into gas have to have enough pressure to push the atmosphere up.
Okay, that does help me. Because I was vapor pressure didn't mean much to me yet.
Right. And vapor pressure is just the pressure that's as a result of the water that's turning to gas and hovering above that surface.
So at a higher altitude, because there's like literally less atmosphere because you're up higher. Like some of the atmosphere is actually below you now.
Yes.
Compared to, other parts of the earth.
Yep.
So there's just less pressure.
Yes.
Whoa.
Less atmospheric pressure.
So that vapor's like, all right, we're ready.
We can push.
Yeah.
It's a little bit easier to push now.
Interesting. Gosh, dang it. Okay. Wow.
So now you know that, and you know the definition of boiling point. What do you think happens when you put the lid on the pot? What are we doing when we put the lid on the pot that could possibly change the way the water boils?
Are we decreasing the atmospheric pressure? Or are we putting a barrier, I guess, or something like that?
No, decreasing the atmospheric pressure would be using a vacuum to remove air that's causing pressure. We
So get your vacuum cleaner and just put it right on top of the pot, and you're good to go.
Yes, please do that. Please do that. Actually, we have this contraption called a Rotovap. It rotates and it evaporates liquid by boiling them off, but you can hook it up to a vacuum and suck the pressure out so that it boils at lower temperatures.
Interesting.
We have a video of that we can put on Instagram that you can look at and see. So that is one way to make water boil faster.
Okay.
If we could put it under a vacuum, suck away all the atmospheric pressure, it would boil way lower. And I have used that technique in my life before. We do not have that in our...
And that's not what the lid's doing. That was, yeah. Okay.
Not what the lid's doing.
So I do not know.
But wouldn't it be funny if we did like a vacuum cleaner up?
Yeah.
Okay. So you don't know. So I'll
Yeah.
tell you.
Yeah.
I wanted to see if you could. There's theories in learning that say if you try to synthesize an answer before giving the answer, you'll learn the given answer better, even if you're wrong.
I believe that. I do wish that I could have landed on it somehow by some miracle. Just logicked it out, figured it out, but I don't know.
Well, you're close. You're focusing on changing the atmospheric pressure. But the other thing that you can change is when vapor pressure meets atmospheric pressure, so you can change the vapor pressure.
Okay.
And the way you change the vapor pressure is by putting a lid on so that the vapor isn't going anywhere.
Oh, okay. Yeah. Because it condenses in on the lid. That's what we're like keeping in.
Well, the lid keeps all the water vapor there in the pot. So there's a higher concentration of water vapor in that area. And as the water vapor increases, the water vapor pressure increases, and it's going to get to atmospheric pressure faster.
That is really cool. Is there a figure or number or estimate of like how much faster a pot of water could boil with the lid on versus with it off?
I actually looked into that to try and find out. I think
it'd be kind of cool if it was like quantifiable, like 5 minutes faster or something like that.
Well, I think that one thing I read said it was like a minute faster. But it would depend probably a lot on the amount of water that you have.
Okay.
And the headspace between where the water is and the lid is. And so I think there's so many other factors, so many other things that could come into play that it would not be reasonable or worth it to quantify that in our kitchens. I think that you can quantify that if you want in a lab. They probably have. I feel like I remember some knowledge about that. If I'm thinking I want to boil this at this temperature, I would have to put it at this pressure.
Yeah.
But I don't think it really would be significant.
Yeah. I guess it's helpful to know that even if it's not significant, it's at least a little bit faster. It's worth doing. It's like if you're making spaghetti or whatever, you got to boil a big pot of water. Just go ahead and put that lid on because you know it'll at least be like maybe 30 seconds to a minute faster. Right.
And if it's a big pot, it might be even faster than that.
Yeah. I had a situation one time where I was boiling water forever. Like I just never got there. I don't know what the heck was going on. It was like, I was like, am I crazy? No, I didn't have a lid on it. That's
funny.
Part of it. I also had one of those like weird things with holes in it inside of it because I was planning on, which might have had an effect. I don't know.
Probably not. Did you put salt in it.
Mm-hmm.
Well, that's a whole other thing that could change the way water boils that we're not going to talk about today.
Not this time, but in a future time, maybe some things like
We
like
could
that.
probably do it in the next few. Yeah, but it's not. It's a whole other topic, so not enough for today. But I bet if you hold on to that forever boil story,
Okay.
you'll have a little insight into what happened when we talk about.
Oh, I'm
salt
holding on
in
to that story.
water.
It threw off our entire evening dinner plan that time. So I was like, what? Am I crazy? Like, is science broken right now? This is supposed to work.
Science was working exactly the way it was supposed to. Oh, that's funny. Okay, so that's it. So now tell me what you learned.
Okay, so the better definition for boiling point is not what I said earlier, but it is atmospheric. Sorry, it's when, oh, dang it. When vapor pressure reaches a point that it can, would you say the word overcome? The atmospheric pressure on it?
It's roughly equal.
Roughly equal. Okay. It gets to, the vapor pressure can build up as the water's getting hotter. It can build up to a point where it is equal to the atmospheric pressure. So that's what boiling point is. And so that comes into play because whenever we put a lid on the pot, the vapor that we're referencing when we say vapor pressure isn't going anywhere and escaping and going out into the air in our homes. And so if we keep that in, then it builds up its pressure faster because it's not also losing a little bit of it at the same time. And so then it becomes equal with the atmospheric pressure a little bit sooner.
Yes.
Nice.
That's it.
That was a fun one, and also a simple one too. I feel like there was not much of a chance of me failing after explaining what was not that challenging of an idea.
Yeah, well, but also I do want to say that when things evaporate, there's an evaporative cooling effect, so it's possible as the vapor is leaving, it's also losing heat. And so there are other things that are coming into play besides that solely, I think.
Yeah.
But that is probably the biggest reason that it is effective to put your lid on your pot.
And it's like, I mean, I guess room temperature is not super low compared to like if you were outside boiling water in the dead of winter in Antarctica. I think probably I bet the like external temperature would have a much bigger effect. But if we're talking like normal boiling, normal room temperature and standard boiling point ish stuff, and you're not in some weird part of the world, then it seems like it'd be the biggest contributor instead of just like, oh no, this 75 degrees kitchen is cooling me down really fast. Like that seems unlikely.
Also, it would probably make a way bigger difference if you were boiling that water at the bottom of the ocean. Like if you could somehow put yourself in a pressurized bubble so that your body is safe, and then put an air bubble around a pot boiling water, there'd be so much pressure at the bottom of the ocean.
That's true.
That lid would probably really matter. And I bet it would be very hard for the water to boil under there. But that's a weird imagination that just came into my mind when you were talking about crazy places to boil water. It would be so cool if we could have a little like art of someone boiling water at the bottom of the ocean. Like fish flying
It's so crazy
by.
because if you could get at the bottom of the ocean and have like a pressurized vessel and stuff like that, and all you do once you get there is just try to boil some water.
But you'd have to boil the water outside of the pressurized vessel.
Oh yeah.
You'd have to be pressurized to be safe, but the water would need to for the experimentoric to feel the full pressure.
Interesting.
Yeah.
Dang. There's probably some better things to do at the bottom of the ocean than
Yeah. The ocean is crazy cool.
Yeah.
The first time I ever went scuba diving, I thought, what am I doing here in this water?
Yeah.
Where sharks live.
Yeah, like everything
is a
about where this
mistake.
is not supposed to be where I can survive.
Yes, it is crazy. It is very it's amazing and terrifying and beautiful.
Like not even the animals. It's like just the same as outer space. It's like, like alone I can't survive. Mm-hmm. I can't just be in outer space. I can't just be under the ocean. Like
It's crazy.
I don't have anything I need here.
And isn't it amazing also that we developed the science and technology to where we could make ourselves be there?
Yeah, it's pretty nuts.
It is pretty nuts. So that's it. That's what I have for you.
Awesome. Dang. That was great. I feel good about myself because there was low risk of me failing hard, and also it was like a fun one to learn.
And now you'll think about it. One thing I do, though, is think about the fact that I should put a lid on the pot to make it boil faster, but I don't really want to dirty up another dish, and I just won't.
Yeah.
And
true.
I think about that consistently.
Yeah.
So.
And then you can't really see yet if it's boiling. That's the other thing, too. Like, if you're doing a few other things, you have to go and take the lid off to do that. So if you're, like, chopping something or whatever, it's like...
Yeah.
Just one more thing you have to like move.
So it might not really matter a ton for those of you cooking at home, but
Yeah.
you at least know. You are knowledgeable and can make a decision based on the information that you have, whether or not you want the water to boil faster with the lid
Yeah.
or slower without.
So you can make a conscious decision instead of a haphazard one.
Mm-hmm.
So Melissa and I have a lot of ideas for topics of chemistry of everyday life, but we want to hear from you. So if you've got questions or ideas, you can reach out to us on Gmail, on Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. And if you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. It helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jan Robinson. Jan Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong, who reviewed this episode.